Okay. All right. Thank you, Nama, for the introduction. Good morning, everyone. My name is Sunny Virmani, and I'm a product manager at Virmani Life Sciences. Today, I'm going to talk about how we can take AI from research and translate that into a healthcare product. And I'm going to use our story of diabetic retinopathy screening as an example to walk you through that. These are my financial disclosures. So this was touched upon yesterday, so I'm not going to belabor the point, but the idea behind machine learning is that we have to find the perfect applications for it. So machine learning can't be applied on everything. You have to figure out what the user need is, and I think the previous speaker was talking about that. You have to find the need before you come up with a solution. So it's perfect for places where there's lots of data to review, and India being a great example of that because we have a huge diabetic population in India. It's a perfect place for it to be. Then also, to add on top of that, expertise is limited. So there are ophthalmologists in India, but we don't have enough of them. An algorithm which can automatically detect diabetic retinopathy in fundus images can help scale those ophthalmologists and reach places where they can't physically go by themselves. And then the other thing is, if you're actually doing fundus imaging for diabetic retinopathy screening, whatever you interpret out of that image is actually actionable. So you can do something about it, either treatment or controlling diabetes and things like that. So all in all, it's a diabetic retinopathy screening, and use of AI for that is a slam dunk application. Like I was talking about earlier, in India, there are about 11 eye doctors for every 1 million people that we have here. However, just to show for comparison, in the United States, there are 59 eye doctors compared to the 11 for every 1 million people here. Now, I'm not trying to say that US has enough ophthalmologists. There is a shortage of ophthalmologists throughout the globe, but we have the problem. The problem is much worse in India, so that's just what this point is. As I said earlier, there are about 27,000 eye doctors, which we have a shortage of. And because of this and some of the other systemic issues in the Indian healthcare, about 45% of the patients suffer vision loss before even they're diagnosed. Now, this could be diabetic retinopathy or other things, but a lot of this is actually preventable, and there's something that can be done about it. So what have we done in terms of doing research for artificial intelligence and machine learning based algorithm? We developed an algorithm back in 2016 and published data around it. For diabetic retinopathy detection and for referable DR, in 2016 we were about on par with general ophthalmologists. Then we made some improvements, which I'm going to talk about a little bit, but in the follow-up paper in 2018, we were on par with the specialists. Now, this point was brought yesterday, so I'm just going to address it, that the idea isn't that AI is trying to beat ophthalmologists. The idea is that the expertise of ophthalmologists needs to be extended at other places where an ophthalmologist is not available. So if our algorithms or any AI company's algorithms can do as well as an ophthalmologist would do, then the shortage of these ophthalmologists can be taken care of in just a different way. So it's not about beating ophthalmologists or replacing them at all. So having said that, like I said, we have published a paper in 2016 which was more about showing the feasibility of the algorithm. Then we improved our ground truth, which I'm going to get into the detail later on. But the idea was to use retina specialists and their expertise to label a certain set of images. You don't have to do this for all of your training set of millions of images, but you can take a smaller subset of images and have them graded and come up with a very precise ground truth, and then train the model, which would show you much better improvement. And then we are also looking into assisted read. For example, if there are annotations we can make on the images, which can help the ophthalmologist become maybe more efficient, or maybe they don't miss those subtle microaneurysms that Dr. Peng was showing in her presentation yesterday. I think those could be also very good applications, not just for screening, but also for diagnosis and management. For other things, you can also improve your reference standards with some finer grading schemes like ICDR, ATDRS. You can adjudicate using retina specialists, which we have shown has definite improvements. You could use OCT derived labels for training your fundus images, and that's something Pino talked about yesterday. Or you can also look into maybe wider field of views and see if that somehow helps, because you will have more things to look at and maybe the algorithms actually perform better. You may have noticed Dr. Peng was showing yesterday a few images where there were subtle microaneurysms and hemes and other pathology which the algorithm looks at or finds those pixels interesting. But this is actually a map. If you look on the right here, this is a map of thousands of images overlaid on each other, just a heat map for that. And as you can see, if you have thousands of moderate diabetic retinopathy images, it has pixels the algorithm thinks are interesting all over the fundus image. However, if you look at the DME example, just like we expect, it's looking at pixels which are centered around the macula. It's a good validation for what humans see and how humans interpret these images for DME versus DR. So it's good to see that algorithms also do very similar things. So we can build algorithms all day long and we can show how they perform, but we cannot really assume that they will generalize really well in the wild or in actual clinical setting. So what we do is we do some deployment research where we find out what the user really wants. I mean, is this algorithm need to be deployed as part of their current workflow, or it has to be a separate software? Then we collect all of this data from various different users, iterate on it multiple times, understanding that do we really understand their requirements or is there more to it? And once all of that is done, like we look at workflows, is there an existing DR screening methodology that is available at your clinic, and are we replacing it or are we becoming part of it because you may be doing more than just diabetic retinopathy? We look at basically if they have data management systems and what are the requirements for integrating into their data management systems. The other things are some more high-level barriers that you need to look at. So what is the incentive for someone to take over a technology like this? If there is no use for them or if there's no additional value for their patients, then you're going to have a really hard time actually getting them implemented and having people be compliant to it. And then we also have to understand the stakeholders, like who is the relevant decision makers, who is going to be the proponent for you at a particular clinic or a particular institution. So all of this put together is important to actually study. So after we built our algorithms in 2016 and 2018, we went ahead and worked with our very close partners in India and Thailand, Dr. Kim, Dr. Rahman, Dr. Paisan, and we ran 2 studies which are already published and available for your reading. And both of these studies show how the algorithm, even in a real clinical setting, can actually perform as well as the human grader, and it can provide similar benefit as a human grader can. So after we did all of this, we realized we can't just, of course, we have to go get regulatory clearance. So we performed a separate clinical study, which included about capturing around 850 images. This was a retrospective study. We used a few different manufacturers of cameras, 45-degree images which were centered around between the macula and the optic disc, or at least had both macula and optic disc visible. We had clinical grades available for these images which were done by doctors, and we used them to have a good distribution of various different DR-DME grades. And then we had them adjudicated, and how that process works is 3 graders would just read these images or grade them individually first, and then any images they don't agree on, they get into a room or a conference call and get an agreement for all of those images, and that's considered the ground truth. And then finally we run the machine learning algorithm on it. So these are just some results. I'm not going to go into the detail, but for sensitivity and specificity of moderate plus or for referable DR, we saw very similar results to what we were publishing in papers earlier, and this was on a test set which was never seen by the algorithm before. So we had around 90.4 and 97.5 specificity. This matrix on the right is something called confusion matrix. You can actually see how the algorithm agrees at each of the level, or if it's not agreeing and within one level. So after we had regulatory clearance, we went ahead and deployed this algorithm at Arvind Eye Hospital, and I'm going to not use my time to talk about that because Dr. Kim is going to actually follow up with his presentation and give you some more detail. But so far we have had impact on thousands of patients, and I've been able to actually screen for diabetic retinopathy. So what's next for us? Pino actually had a great presentation yesterday on, this is basically a summary slide of that. So there's a bunch of things that you can do from fundus imaging. Cardiovascular, explanation of how the models work. You can use OCT-derived labels and actually predict DME using fundus images. So I think all of these things will help us empower doctors with more and more tools that they can use today. It will help us take expert care that ophthalmologists can provide and extend it to a general practitioner, and overall it will improve the clinical workflow. With that, I would like to thank the organizers for inviting me here, and thank you to all of you for listening.